Welcome back. Our focus is now going to go to page 13 of the definite integrals packet at the bottom with this geometric exercise here. And I'm looking, count them, wow, 4 through 11, so 6, 7, 8 different questions, all about area under a curve at different points on this picture. There's a typo in number 11 if you haven't already, if you want to change that lower limit of integration to a -9, so it's not the same as number 8. And I'd say, man, if we're going to get asked this many questions, it's worth our time to just go through left to right and label up the diagram with some areas that we can get off the bat. So start with this triangle here. Area is 1/2 base times height. So 1/2 times 2, 1/2 times 2, the base, times what the height is 4. It looks like here each tick mark on this picture counts as 1 unit. So we'll just say this is a 4 square units of area. That's a little hard to see in green there. So 4 square units of area above the x-axis, so it's positive. What about below the x-axis? I'm going to go, instead of trapezoid, I'll do a little skinny triangle versus a bigger rectangle. So 1/2 base times height. 1/2 times 1 times 2 gives you 1 square unit of area. And I'm going to label it as -1 there because it's below the x-axis. What's this negative area? Length times width, 2 times 3, so -6 square units of area below the x-axis. Let's do the entire semicircle. We know area of a whole circle would be pi r squared, and a semicircle would be half of that, 1/2 pi r squared. Well, just find r in this picture. It's not perfectly drawn. I'm the one who drew it, but I meant for the radius to be 3 units long. So it's 1/2 times pi times 3 squared. So 1/2 times pi times 9, we can say 9/2 pi or 4.5 pi, either way, and that's positive area above the x-axis. 2 more triangles. What about this one below? So 1/2 base times height, 1/2 times 4 times 2, you could say, is just the number 4, and we'll call it -4 below the x-axis. How about above the x-axis here? 1/2 times 2 times 3 gives you 3 square units above. And this can all be used. Notice, okay, so -3 to 3. Looks like they're just talking about -3 to 3 is just the area above the x-axis of this semicircle. Here's 3 and -3. So we already got this as 9/2 pi, positive above the x-axis. All right, keep it going. 3 to 7. 3 all the way 4, 5, 6, 7 to here. We want to add, oh no, just 3 to 7, just the triangle. So we got that as -4, right? And -3 to 7 is the whole semicircle plus this negative area. That gets you all the way to 7. So it'd be 9/2, basically the sum of the two solutions we just got. 9/2 pi plus -4. This is your exact answer. If somebody needed a decimal, we could just approximate it using the calculator. -3 to 9, -3 all the way up, 7, 8, 9. So we got part of that in number 6. 9/2 pi minus 4 was the area all the way up to 7. If we want to add 2 more units, add that 3 that's above the x-axis plus a 3. So basically your answer to 6 plus the area of this triangle. And you get 9/2 pi minus 1, exact value. All right, absolute value symbols mean total area versus net area. So for the next question, it's still the same limits of integration, -3 all the way to 9, but count all this area as positive. We'll have 9/2 pi plus 4, we're going to use the absolute value of this, plus 3. So how about 9/2 pi plus 7 square units? Number 9, 3 to 7. Ooh, I thought we had done that one before, but now this one says -f of x. So that is going to be the opposite sign of the answer that we got to number 5, the integral from 3 to 7 of the function f of x. So we got a -4. Let's take the opposite sign of that and just call the answer to number 9 4. 2 more. 10 says -9 to 9. That's almost everything, right? Oh, it is everything, right? -3, 4, 5, 6, 7, 8, 9. They want us to add all this area up, so left to right. So we've got how much? 4 above the x-axis. I'm starting with that triangle. -1, -6, so -7. That's below the x-axis. Plus 9/2 pi, that semicircle's above the x-axis. -4, we're below the x-axis. And then plus 3. So again, we've got that 9/2 pi that's popping up in a lot of these solutions, and then add up the numbers. I think you get -4. Phew, and that was a lot. Last but not least, number 11. I've changed it so that it's -9 to 9, but we want total area, not net area. So let's add these up all positive. So one more for the road. We've got 4. Instead of -7, let's add 7 for this trapezoid. Let's add 9/2 pi. Let's add 4 because we're talking absolute value here. So +4 +3. And finally, 9/2 pi plus the number 18 should do the trick in either order there. Pretty good, pretty good. So geometry got us all of those solutions. Lastly, I want you to flip a few pages ahead, past 14, past 15. Your homework is going to come from page 16, and I was thinking we would end with giving you a little head start on it. Look at some interesting ones. Also, can I point out, my favorite emoji is at the top. The salad emoji made its way to page 16. I fully have confidence in your ability to look at 1, 2, 3, and 4, and 5 and 6. But I wanted to try one of those two with you as a head start. They're both good. I would circle them both as being good thought-provoking questions, but 6 maybe just has a little more substance to it, so we're going to try that one, starting that one off together. Now, why am I just honing in on questions like 5 or 6? Notice the ones above it, 1, 2, 3, and 4, can just be integrated normally, but I feel like with 5 and 6, you've got inside and outside parts of functions, you have multiplication and division. I think I hear Soldier Boy calling. It's time for a little U substitution. So for 6, I say you're going to have a much better time integrating it if we can pick a good U choice. Are you going to pick this expression here, maybe this expression inside the radical? Keyword inside, right? Pick the innermost part of the function. That's to a higher power too. Okay, so we'll try a great review of some U sub. This is all your side work. Remember this? We take a derivative. We find du dx, the derivative of u, with respect to x. So derivative side work is 4x to the third plus 4x. And I guess that's it. And we solve this for dx, right? Dx by itself, and we hope for the best. I say give this one a circle and a star too. Okay, let's go back to the original. We are still integrating from x equals 0 to x equals 1. I'll put that here and here. Nothing to plug in for this at first. We're just hoping we can finagle things so that it'll cancel. We have square root of a bunch of stuff that we called u, right? We're using both of these expressions. So u goes in here, that's pretty nice. Times, instead of writing dx, we can write what's circled down here. Du over 4x to the third plus 4x, and here we pause. This is the step. This is one of those good ones where at first it looks like, ugh, how are we going to get this to cancel with that? But as you look at those two expressions, do you notice a connection between the two? Do you notice something that you could do to this that could make it look a lot more like that or have that as part of it in there? And I'm hoping you're thinking, maybe I will factor. So we'll momentarily leave the x cubed plus x. We'll leave the square root of u. We'll deal with that in a second. But do you notice this is the same thing as that, just multiplied by 4? We're going to do not a full GCF. We're not pulling out a 4x. Let's just pull out a 4. So that what you have left is exactly what you wanted to cancel. Now I'm liking this because we can cancel these two expressions with one another, and everything that's left over is going to be easy to integrate. You might want to remind yourself that these limits of integration are still x values, so you're integrating from x equals 0 to x equals 1. And what are you integrating? You're integrating, don't forget about this 4, so maybe you'll have a constant out front, 1/4. And how about a power for u to the 1/2 power, right? That's the square root of u, and we're taking this all with respect to u. Next step is to integrate, and then we'll do the sub back in. Okay, so take an integral, leave the constant. Think of a power u is going to be raised to. 1 higher than 1/2 gives you 3/2. And in an integral, we multiply by the reciprocal of 3/2, so we'll put a 2/3 out front. And then instead of a plus c, this has to be evaluated. Don't plug in these values yet. Wait till we have this in terms of x. That's why I'm writing those little x equals to remind ourselves that those are x values. This simplified should be 1/6. And then you have u. Instead of u, we'll write what u equals. So x to the 4th plus 2x squared plus 1 to the 3/2 power evaluated from 0 to 1. Now we can plug back in for x, and you can use your algebra skills or calculator to help. Feel free to leave the 1/6 out front completely from this answer and just do the plug-in with the inside. The 1/6 really does apply to everything, but you'll have 1 plugged into all 3 parts. So 1 to the 4th plus 2 times 1 plus 1 to the 3/2 minus 0 plugged in for all the x's. So 0 to the 4th plus 2 times 0 squared plus 1 to the 3/2. Okay, pause, feel free to simplify slowly. This is going to be 4 to the 3/2 minus 1 to the 3/2. And you get 1/6 of, I think, 8 minus 1. Exact value answer 7/6. You could also give me that answer as a decimal. 1 and a 6 would work too. I'm going to leave the rest to you. A little piece of advice with 7, where this homework ends, area below the x-axis and above this curve. My advice is the biggest reason you need the picture for this is to get the limits of integration. I know you can predict that this will be a parabola that opens up, but just like in the example problem we did in part 1 of the video, you want to find the x-intercepts first. That's your ticket to setting up this integral correctly. So your x-intercepts, you can solve this. 0 equals, and maybe just factor this side, x times x minus 4. And this will do the trick. You have x-intercepts at 0 and 4. This thing is going to open up. It's going to be a parabola that opens up. You could get a vertex to figure out how far down it goes. It doesn't matter much to the integral. And in pre-calc, the quickest way to get the, I'll call this vertex, sorry, that's a bit sloppy, is to do the x-coordinate of the vertex is going to equal negative b over 2a in the original. So x equals negative negative 4, so 4 over 2 times a, 2 times 1. So the vertex is at 2 comma something. You can go back to the original and plug in 2 to get what the y is going to be. 2 squared is 4, minus 4 times 2 minus 8 gives you negative 4. So you have a vertex at 2 comma negative 4. X equals negative b over 2a. And you just get a better picture of this. 2 comma negative 4 is the vertex. So not the prettiest parabola that I've ever graphed, but now I have a good sense of what the area looks like. I have a great sense that I'm going to get a negative solution for this. And when you set up your integral, you've got area equaling the integral. Now you have your limits of integration because you found those x-intercepts. You're integrating from 0 to 4. That was the biggest reason we needed the picture. X squared minus 4x dx. And you're going to take it from there. Have an excellent day. I never gave you a joke for today, so here's your joke. Why was Cinderella so bad at soccer? Because, guys, she was always running away from the ball. Okay. All right, have a great day.